For the last decade, artificial intelligence was largely a digital experience, but that boundary is now dissolving as machine intelligence begins to move out of the screen and into the physical world. Digital-only models are reaching a data wall. They have consumed nearly all the high-quality, human-written text available on the internet, causing a plateau in the capabilities of pure language systems. To evolve further, researchers are concluding that AI must interact with the three-dimensional world. It needs to learn from the immediate feedback of gravity, the resistance of friction, and the constraints of physical space. This shift toward physical embodiment aims to translate digital intelligence into machines capable of navigating and performing tasks autonomously in human environments. This transition is complicated by Moravec's paradox, the observation that high-level logic is computationally simple, but basic motor skills, like folding a shirt or clearing a table, are extremely difficult for an algorithm to master. Companies are attempting to bypass this by using massive virtual simulation engines. These platforms allow a model to attempt physical movements and learn from millions of failures every second before the software ever touches a piece of steel. The shift is significant enough that OpenAI has reopened its dedicated robotics division, seeking to merge its advanced cognitive models with hardware that can manipulate the real world. Cracking physical movement bridges the final gap between abstract programming and true real-world autonomy. NVIDIA is positioning itself at the center of this transition, providing the specialized computational brains for every autonomous machine being developed today. CEO Jensen Huang projects that a global economy will soon require 1 billion humanoid robots, leading to a future where autonomous factories are essentially large-scale robots building other robots. This growth is fueled by breakthroughs like reinforcement learning tokens. This method allows models to master millimeter-precise movements through trial and error in mere minutes, rather than months of manual coding. Startups like Figure AI and 1X are now competing to deploy these rapidly evolving brains into commercial bipedal hardware designed for the workforce. The immense capital flow into these companies is currently assembling the foundation for a trillion-dollar industrial supply chain. But the expansion into physical AI carries a massive hidden cost. Providing a body for an AI requires a surge in global computing power that our existing grids were not built to handle. Electricity demand is so intense that tech companies are partnering to reopen dormant nuclear facilities, like 3 Mile Island, simply to sustain their data centers. In regions like Milwaukee, utility companies canceled the retirement of high-emission coal units as a direct result of rising energy demand from new data centers. This diagram shows the scale of the water footprint required to keep these systems cool. At a ratio of 2.4 gallons per kilowatt-hour, a single facility can withdraw over 22 million gallons of fresh water in a year. These withdrawals drain the municipal water tables of western United States communities that are already facing high levels of watershed stress and drought. The futuristic promise of humanoid robotics currently depends on the industrial reality of burning coal and the depletion of local drinking water supplies. This competition has evolved into a superpower race, moving beyond who can develop the best software to who can mass-produce the most physical hardware. This chart illustrates the industrial gap. China installed nearly 300,000 robots in 2024, roughly 9 times the US volume. And building American humanoid robots without Chinese precision components would nearly triple production costs, potentially stalling domestic innovation. These economic realities have caused concern in Washington, leading to the proposed American Security Robotics Act, which would ban federal agencies from purchasing Chinese-made humanoids. The ban stems from fears that roaming robots, equipped with cameras and sensors, could serve as mobile intelligence-gathering platforms for foreign governments. Physical AI is forcing a bifurcation of global technology, turning supply chains into the modern front lines of a new Cold War. While generative AI impacted white-collar creative roles, physical AI is moving toward the bedrock of the physical economy. The disruption centers on a massive sector of the workforce. Physical human labor currently accounts for more than half of the world's gross domestic product. History provides a precedent for this tension in the 19th century Luddites, who rebelled against the initial wave of textile automation threatening their livelihoods. As factories and warehouses move toward full automation, we're left to see how society will manage the social friction that follows when human labor is no longer the primary requirement. Moving artificial intelligence into the physical world is seen as the only way to accelerate its intelligence, yet this very progress tethers it to the finite resources of the planet. The technological achievement of creating a mechanical mind that can learn and move is colliding with the prospect of mass physical displacement for the human workforce. These autonomous machines are actively being integrated deep into our infrastructure, replacing fundamental human physical capabilities with a startling degree of permanence. We spent decades teaching machines how to think. Now that we are giving them physical bodies, we have to determine the role of humanity in a society where it is no longer the primary engine of labor.